In this lesson, we're going to look at continuous data and specifically the domain and range of continuous data. And some of the things I want you to think about are what are some characteristics that help us identify continuous data, help us write, what are some things we need to know when we write the domain and range of continuous data. So lots of things that you could discuss there. Okay, now I'm using my new document cam, so bear with me. Hopefully I won't have any issues here. So we're looking at domain and range of continuous data, and I've gone ahead and typed out a bunch of information for you here. Remember, if you're writing this down, take a minute and pause the video and copy all that information down. Now we've already defined domain as the set of all the x values, and we've defined the range as the set of all the y values. Okay, so let's talk about what continuous data is. Okay, continuous data is data that can take any value. It can be measured at any value or at any point. And another way to think about that is any number. And I'm going to give you some verbal examples in just a second. But it's basically meaning we can measure at 1.5, 1 2/3, 1.67893. Any number can be represented by continuous data. Okay? Any type of number. Now, here's some important things to know about the domain and range for continuous data. It is always written as an inequality, or sometimes it could be all real numbers. But if the data is continuous, you automatically need to be thinking inequality, sometimes all real numbers. Okay? If our graph has one limit or one endpoint, and I'm going to show you some examples down at the bottom. If it has one endpoint, one limit, then it's going to be a regular looking inequality like this. Okay, that would be an example of a domain because we're using x. If the graph has two limits or two endpoints, then we're going to actually write what we call a compound inequality. And if the graph has no limits, then it will be all real numbers. Now I want you to be careful about this. It can be all real numbers, but maybe not both domain and range. Sometimes it could be both, but sometimes it might be one or the other. So keep that in mind because we'll look at an example down below. Okay, so here's some verbal examples. Okay, the first one says that the function t equals 19m plus 65 represents the temperature in degrees Fahrenheit of an oven after preheating for m minutes. This is an example of continuous data, and you may be saying, well, why? The reason is that we can measure the temperature at any number of minutes. I can measure the temperature at any number of minutes. Okay, I can measure it at 1.5 minutes, 1 minute, 1.3 minutes. The minutes, I want you to notice, is the independent variable. So as we're looking at this, I want you to think about what's the independent variable? Could I measure it at any number? Sometimes if you think of a crazy number like 2.678, could I measure that at 2.678 minutes? Technically you could. You may not see that on your oven, but you definitely could. So this is an example of continuous data. Okay, the next example. The function y equals 3.5x plus 2.8 represents the cost of a taxi ride of X miles. Now, you probably have never ridden in a taxi because we all Uber these days, but taxis have meters on them. taxi meters, right? And as soon as you get in the taxi, they start the meter and it starts calculating. And so you can measure any number of miles. It's kind of like on the gas tank. If you fill up your tank at the gas station, if you'll notice that it does measure to the thousandths or further on the gas tank. So it's the same kind of thing. We could measure any number of miles and it would calculate how many dollars that is. And so that is also continuous. Okay, and then this last example says the function y equals 25x plus 500 represents your monthly rent y in dollars when you pay x days late. Now, this would be my independent variable again, and so I want you to ask yourself, can we measure, or are they going to charge us for 1 1/3 day late? And the answer is no. They are not going to charge us for random numbers of days late. Okay, they might charge us for 1 day and 2 day and 3 day. So this one is actually not continuous because we can't measure any given number of days. Okay? Now I will say continuous is difficult, and we're breaking this apart into multiple days so that we can really think about it. So we're only focusing on continuous, and so that's what I want you to ask yourself is, can you measure this with any number? If you can, then it's continuous. If you can't, if it has to be, whole numbers or just integers, then it's not going to be continuous. Okay, so let's look at our graphs now. Now the key thing I want you to think about with continuous is that the graphs will be lines. Okay? The graphs will be lines. Now I want you to notice that these lines don't all have arrows on the end. So if there is any kind of line, it's continuous. It has nothing to do with what the endpoints are. Okay? Now, I told you up here that gave you some specifications about the endpoints. So I want you to notice on this endpoint, we have on this graph, we have a circle, and then we have an arrow. Okay, so this basically has one endpoint. It has one limit, one endpoint. So when we write our domain and range, it's going to be like a regular inequality. Okay? Now, the domain, remember, is all of our x values. All of our x values. And so what I like you to do is look at just your x-axis. Okay? Here at -4 is one of our ends, right? It stops right there, we know that. And then all of the other x values go this way. And because it's got an arrow, it keeps going and going and going and going. And so we're going to describe this. X, our endpoint is -4. And so x, all of these x values are greater than -4. Now we have an open circle. And remember from inequalities, open circle means not equal to, so we wouldn't put an equal to. The domain would simply be x is greater than -4. Okay, now for our range. I want to look at the top and the bottom of my graph. So for my range, here is the very bottom of my graph at 1. And then, yes, we have an endpoint right here, but this side keeps going. So that means all of our y values keep going. Okay? So we would describe this now as y, because that's range. What was the bottom, the lowest point? The lowest point was 1. Y, all these y values are greater than 1. Since it's a line, we are going to put equal to. So if it's a line, that's just like a closed circle. Okay, let's look at the next one. Okay, on this next graph, we actually have 2 arrows. So this is going to be that third case where it says if it has no limits. Now, we've got to be really careful here. So my domain, my x values, they keep going on and on and on in both directions because the graph is continuing to go outward and spread. So the domain would be all real numbers. Okay? But our range is a little bit different because there is a limit to the bottom of my graph. So there's the bottom of my graph. All of the other y values are going up. So my range, the lowest point was -5. Everything is greater, so y is greater than. It's touching -5, so that means it can also be equal to. Okay, last one. So I do want you to notice that we've got 2 endpoints here. Okay, so here's my domain. And let's look at my x values. So let's see, my edge of my graph on the left is right here. And then on the right is right here. So I'm trying to describe all of these numbers in between here. Now this is really super easy. All you have to do is write the lowest point number, -4. We're describing domain, so x goes in the middle. The highest number is 3. Lowest number, -4. Highest number, 3. All you have to do is put in less than signs. It's always going to be that way when we write a compound inequality. Okay? The only thing we have to decide now is, do we put equal to? So on -4, it's touching it, so it's like a closed circle, so yes. But on the 3, we have an open circle, so we do not. Okay, always put less than signs. If you are putting the lowest on the left and the highest number on the right, it's always less than signs. Okay, and now for our range, we're going to do the same thing. The bottom of our graph, the top of our graph. And I'm going to shade this. Okay, my lowest number is -5. My highest number is 5. This time we're talking about range, so I'm going to put a y value. Always a less than sign. Always a less than sign because we're describing what is in between. Okay, so now let's decide if we need equal to. Here I've got an open circle, so that's not equal to. At the top, open circle, so that's not equal to. And that's it. That's how we do domain and range on a continuous graph.